Reactions in haloalkanes. There are two reactions in haloalkanes, which are elimination and substitution. Elimination, the reactant is haloalkanes, reacts with base in the presence of alcohol and then heat. The product is alkene and side product hydrogen attached to the halogen atom that is in haloalkane. For substitution, it reacts with base. The nucleophile will be, here example, OH group is the nucleophile, the nucleophilic site OH, replacing the iodine in this example, resulting alcohol and iodide. Nucleophilic substitution. So haloalkane reacts with nucleophile. This nucleophile will substitute the halogen atom that is attached to the R group, that will be the product, and the leaving group, the halogen ion, halide ion. A nucleophile replaces a leaving group on sp3 hybridized carbon. So this is sp3 hybridized carbon. Nucleophile here replaces leaving group X, and the nucleophile will attach to the sp3 hybridized carbon. Nucleophiles can be divided into strong and weak nucleophile. The strong nucleophiles are OH minus, for example, in NaOH, in KOH. Weak nucleophile, water. And then OR negative, for example, CH3O negative. So R can be O attached to any carbon or alkyl group. So for example here, the R is CH3. And then weak nucleophile, ROH, R, any alkyl group, for example CH3OH. So strong, OR, O negative. Weak, R bonded to OH. Okay, different. These two are different. The ROH, here, the R is the alkyl group and it is with OH. This R here is with O negative only. There's no hydrogen. And the difference between these two, this OH negative, it is from NaOH or KOH, not from the R group. But for this one, this is not OH negative. This is the whole thing CH3OH. The whole thing here is weak nucleophile. R group attached to OH, the whole thing weak nucleophile. Strong nucleophile, CN negative. This is from NaCN or KCN. And weak nucleophile with N atom, for example, NH3. Another weak nucleophile, CH3COO minus. This is an example of weak nucleophile. Reaction with NaOH. So this is the reaction of haloalkane with sodium hydroxide. Haloalkane, we have alkyl group in this haloalkane, reacts with nucleophile. Remember, this is NaOH, strong nucleophile. So the OH minus here is the strong nucleophile. This OH minus will replace the Cl in the haloalkane, and it will become CH3OH, and Cl minus will be the leaving group. This is reaction with NaOH, strong nucleophile. Next, reaction with alkoxide ion. Haloalkane reacts with nucleophile alkoxide ion, O negative with R group. Okay, alkoxide ion, O negative with R group. This alkoxide ion will replace the Br here, and it will be CH3CH2O CH3. O will be bonded to the sp3 hybridized carbon over here. The O will be bonded with the C, not carbon, oxygen here. And then the Br will be the leaving group as bromide. Reaction with excess ammonia, weak nucleophile. This NH3 over here will be the weak nucleophile, reacts with haloalkane, and then it will replace Br, but not NH3, the whole thing will replace Br. Only NH2 will replace the Br, and the side product will be Br minus leaving group and NH4 plus. So NH4 plus means the NH3, another NH3 molecules with the hydrogen atom from NH3. That is nucleophile. So NH3, not the whole NH3 replace Br, only NH2 will replace the Br. So that's why the product will be R group attached to NH2, and then NH4 plus, side product, and Br minus. So this NH4 plus Br minus is a leaving group. And then reaction with KCN or NaCN. This is strong nucleophile. Cn minus, cyanide ion, comes from KCN or NaCN, strong nucleophile. The Cn, the cyanide ion, Cn minus, will replace the halogen atom in haloalkane. It will replace the Cl over here, and the C will attach to the sp3 hybridized haloalkane, the leaving group chloride ion. Next, reaction with alcohol. The haloalkane reacts with alcohol. Here nucleophile, alcohol is the nucleophile. The OH here, not the OH. Okay, the nucleophile is not the OH. It's the CH3O negative. When it reacts with nucleophile alcohol, it is R group O negative will be replaced the Cl. R group O negative. Alright, so that will make the product OCH3. The CH3O negative will replace Cl, and then the Cl will be the leaving group, Cl minus leaving group, and the Cl bonded to hydrogen from the alcohol over here. Next, reaction with acetate. Haloalkane with alkyl group CH3 reacts with acetate. This is acetate, act as the nucleophile. C double bond O, and that C attached to O minus. This is acetate. The C double bond O attached to O minus. The acetate here will replace the halogen atom in haloalkane to be acetate with R group, and the Br here will be the leaving group as bromide. Next, reaction with water. Alkyl group reacts with water, and this alkyl group over here, when it reacts with water, the OH will replace Br, and the leaving group is HBr. If you look at this, is the difference in the leaving group. They will reaction with water and reaction with sodium hydroxide. Look at here, alcohol as a product, OH replace the halogen atom, reaction with NaOH, but the leaving group is the halide ion only. That's with reaction with NaOH. But reaction with water, the product will be alcohol as well. Here, the product will be alcohol, same as the reaction with NaOH, but the leaving group is different. The leaving group is halogen atom attached to the hydrogen from the water over here. So that's why it's HBr. So that's the difference between reaction with water and reaction with NaOH. Both will produce alcohol, but their leaving groups are different.